All right, guys, another set of video notes here. This one's about balancing equations. You should remember most of this stuff from before, and you can pause here in the video and write anything down that you don't remember. Save a little time on the video, though. Big thing is we have chemical formulas which tell us the molecules. So H2O2 and H2O, those are the molecules we have. We have subscripts, which are the little numbers in each of those chemical formulas that tell us how many atoms of each element we have in that molecule. So in this case, we have 2 hydrogens in a molecule of H2 gas, 2 oxygens in a molecule of that, and 2 hydrogens, 1 oxygen in a molecule of water. If there's not a subscript there, we just assume that it's 1. It's like an invisible 1 that lives there, because chemists don't like to write 1s, apparently. And the coefficients are the same kind of deal, except they go in front of the molecule, and that tells us how many molecules you have each. Not how many atoms, but how many molecules. So this one's saying that we have 2 whole molecules of H2. Again, invisible 1 whole molecule of O2, and 2 molecules of H2O. And again, the reactants are on the left side because we're reacting them together, products on the right side because they are produced. If we look at the number of coefficient, or we look at the coefficient numbers and the subscript numbers, we can count it up, if we do it right, how many atoms we have of each element. And that's the whole basis behind balancing equations. There are 4 main steps that are really easy to follow if you just do them one at a time and do it very meticulously. You start out by writing down, you look through your equation and see all the different elements you have and write down the symbol for each of those elements in a line, a vertical line underneath the arrow in the equation. After you do that, you need to count up how many atoms of each of those elements you have on the left side. And you write that number to the left of the chemical symbol that you wrote down. And then that tells you how many atoms you have on that side. Do the same thing for the right side. That's step 3. Step 4 is to look at those numbers, and if you see any that are not the same on the left side as they are on the right side, then add coefficients to whatever molecule you need to in order to fix that. And it'll make more sense when we go through the example here in the next few slides. But essentially, after you after you add a coefficient, you need to stop and reevaluate, recount how many atoms you have on that side. And then you just keep repeating step 4 until you end up with the equal number of atoms for each element on each side. Again, never ever change the subscripts. Changing the subscripts in a chemical formula changes the identity of the molecule you're working with. So that would be synonymous with trying to bake a cake and following a recipe that calls for 8 cups of flour, but instead of flour, you decide to use 8 cups of powdered sugar. That's not going to fly very well, and you're going to have a really messy oven. So don't change what you're working with, just change how much of it you're working with. And that's what the coefficients are for. After you get it balanced, it will show us the law of conservation of mass because we'll have the same number of atoms at the end of our equation as what we began with. So we didn't lose or gain anything. So first example, we have 2 different elements here, hydrogen and oxygen. We'll write those underneath the arrow. That's step 1 out of the way. Step 2, count how many you have on the left side. We have a little subscript here next to this H saying we have 2 H's, or we could look at the picture down here. There's 1, 2 H's. Same thing for oxygen. On the right side, we've got 2 H's and the invisible 1 oxygen. Again, if you look at the picture, 2 H's, 1 oxygen. Now you notice H's are balanced, but oxygens are not. So you could add, what you need to do is find the side that you're deficient in oxygen on. This side has less, so you need to add another one over here. So instead of the invisible 1, we're going to write 2, add another molecule of H2O, and then stop and recount how many atoms you have on the right side. Now we have 2 H2Os, which gives us 1, 2, 3, 4 hydrogens, because 2 times 2 is 4. And 2 oxygens, because 2 times 1 is 2. Now we're balanced for oxygens, but our hydrogens are messed up, so we need to go back to the left side and say, all right, I need to add more hydrogens, and I'll do that by adding one more molecule of H2 to the one I already have. Now I have 2 times 2 H2s, gives us not 2, but 4 hydrogens, and if you look here, we now have 4 hydrogens on each side and 2 oxygens on each side, which give us a balanced and a happy equation. The next practice problem is a little more difficult because we have 3 different elements to look at. We have sodium, oxygen, and hydrogen. We count everything up on the left side. We have 1 sodium, 1 oxygen, 2 hydrogens. On the right side, we've got a sodium, an oxygen, 3 hydrogens, because we have these 2 over here plus this 1. First step, you're running low on hydrogen over here, so add a molecule that will give you more hydrogen. In this case, it'll be H2O. So we go from 1 to 2 there. Stop, recount the left side. We now have 4 hydrogens and 2 oxygens. That still doesn't get us any closer to really being balanced as far as how it looks right now. But if we go back to the right side, now we're deficient in both oxygen and hydrogen. And we can fix that by adding another NaOH. So we go from 1 to 2 of those, add another one, stop, recount. We now have 2 oxygens because 2 times 1 is 2, and 4 hydrogens because 2 times 1 is 2, plus this 2 over here. But that also changed our number of sodium from 1 to 2 because 2 times 1 is 2. And we're still not quite balanced, but it's a super easy fix because we have a single sodium over here. We can just take that, add another atom of that, stop and recount. And now we have 2 sodiums on both sides, 2 oxygens on both sides, and 4 hydrogens on both sides. That gives us a balanced and happy equation. Last problem, same idea. We got 3 different elements, zinc, chlorine, and hydrogen. Count up the left side, we have 1 of each. Count up the right side, we have 1, 2, and 2. We're deficient in hydrogen and chlorine on the left side, so we add another HCl. Stop and recount. That now gives us 2 Cls. And it also gives us 2 H's. And that gives us a balanced and happy equation. If you have any questions about this, be sure to ask me. I can walk you through some more problems. But other than that, good luck.